Well, with that, we were lucky enough to be graced with Roberto making it in here in time from his last panel. So he was scheduled on two different presentations at the same time, but he made it here in time for his video. So let's start with that video.
I would like to thank the organizers of the GFN for inviting me to present this video, which summarizes research undertaken by myself and by my colleague Sebastian Soulet. I will focus on preclinical studies using the INEXPOSE manufactured by CIREC. It is a commercially available computerized system specially designed to generate vape aerosols and deliver them to exposed cell lines and rodents. Practically all studies using the INEXPOSE claim that their experimental results on cells and mice show high likelihood of serious biological harms from vaping. As an example, one study, the authors exposed pregnant mice and found adverse effects in their offsprings. The press release extrapolated these results to human pregnancy. It was quite scandalous. To probe these worrying outcomes, we looked systematically at preclinical studies using the INEXPOSE under the same aerosol-generating experimental conditions. We did a literature search that found 40 articles on same experimental conditions. The articles, some provided sufficient information, some insufficient information, but we managed to synthesize it. The default device used by the INEXPOSE is a third-generation tank, the EVIC Mini. It is a high-powered device, a sub-ohm, and the INEXPOSE restricts the puffing of this device to an airflow between 1 and 2 liters per minute. This is appropriate for low-power devices running below 20 watts. We became suspicious when looking carefully at the promotional video of the INEXPOSE. At the beginning of the experiment, the liquid in the tank was colorless, but at the end of the experiment it acquired a brownish color. This is a signal of pyrolysis of the cotton wick, and it clearly shows there is overheating. The authors reported very different parameters, all taken from the EVIC screen that you can see below in the right. Voltage, power, temperatures in these ranges. However, we have to calibrate that. We have to verify if these values in the screen of the device had something in common and if it matched laboratory tested values. This is the result of the calibration, and I summarize it here. All experiments were conducted by puffing the EVIC Mini with a 0.15 ohm coil at power levels between 40 and 45 watts with airflow rate of 1 liter per minute. We replicated the puffing to verify if it was done under normal or overheating conditions. We also quantified the presence of toxic byproducts, mostly aldehydes in the aerosol. And this is what we found. It was actually puffed, the device, under the overheating regime. If the authors had wanted to obtain an aerosol without overheating, they should have puffed the device between 14 and 31 watts. Regarding the toxic byproducts, at the level of 40 to 45 watts, we find a 20-fold increase in toxic byproducts. The authors claim their experimental outcomes predict harmful effects in vaping. However, all the studies exposed cells and rodents to aerosols that were generated under overheating conditions, loaded with excess toxic byproducts, and the puffing was done in a way that is unrepresentative of consumer usage. I have to say something about the device. When the EVIC Mini was released, it was a technologically advanced product, among the first devices allowing for user-controlled temperature or power mode. However, since 2020, it has become an obsolete relic that almost no vapor uses. It is very difficult to find one in retail shops. Therefore, it is questionable to use this device as a standard default for studies published so recently between 2020 and 2024. We identified 105 research projects funding the 40 studies. The total funding is well over $10 million US dollars, and it mostly comes from US government sources. Are there more preclinical studies with same methodological problems as the one we found? Yes. We found over 67 studies not using the inexposed but with the same problems. This means that there are likely much more studies under this condition. Thanks for watching.
Do we have any questions? See a question right here?
Norbert Schmidt, consumer. I wonder how many good studies did you find? Studies which represent normal use.
Bueno. Okay. Look, here we identified a methodological short circuit, which is, it is also a type of puffing that does not correspond to consumer usage. High-power device with a low airflow. If anybody has taken one of these powerful tank devices and puff it as if you would be puffing a pod, you will get a hot aerosol in your mouth. The reason is very simple. In simplified ways, I can explain it, is because a powerful device generates a lot of vapor. But that vapor you have to evacuate to produce the aerosol by condensation. The user does that, right? But if you inhale it in a weak form, you're not going to evacuate sufficient vapor. And this, puff by puff, this hot vapor accumulates. So this is the reason why these devices are puffed with a direct to lung, which is a large airflow. Now, we identified this particular methodological problem. Other studies that have tested, for example, pod devices, see, then we did not examine them because, as you can see here, we are looking at the aerosol generation, not at the biological issues, right? But we believe that if the aerosol is generated under overheating conditions, then the rest of the biological study is irrelevant because we are studying some toxicological data that it does not correspond to real usage, okay? So we did find studies that were well done in this respect. We did not look at the biological conclusions, but we noticed that the aerosol generation was correct. And here the problem is the airflow, right? When you're puffing devices with different power, it doesn't matter so much the puff length and the interpuff lapse. As long as, for example, the Coresta protocol would be okay. But if you are going to try a powerful device, you have to use a much larger airflow. Otherwise, you get overheating. But unfortunately, all the studies that we have seen use a Coresta or Coresta-like airflow. And so, as long as the high-power devices are examined, we're going to see this problem. And it is very extended. We have found more than 100 studies, mostly preclinical, but there are also emission studies, and there are bound to be more, right? So to answer your question, yes, we did find, in this respect, aerosol generation studies that were correct. But I cannot say anything about the biological part of the study.
You have another question?
Anna from Italy. Do you think that the type of e-liquid can also get the things worse and worse? I mean, the issue with the study focus on the type of device, but probably also the type of e-liquid can also worsen the situation. Using probably, I don't know, an e-liquid based on VG with a nicotine salt at a high concentration probably can get the thing worse and worse. So do you think that maybe also an evaluation of the type of e-liquid that is used for this kind of study can be necessary to understand how bad the voices around vape can be based on what the press is telling to people?
Yes, no, very, very good question, very appropriate question, because a parallel question could be, of all these 40 studies, did they use the same e-liquid? Of course not. They use different types of e-liquid, but also the type of e-liquid that these studies used, most of the times, not always, is different from the consumer usage of these devices. Like high-power devices normally are used with liquids that are predominantly that are dominated by glycerol. There are physical-chemical reasons for that, and also you don't use high nicotine levels with such devices because the flux of nicotine would suffocate you, right? That's why high levels of nicotine, especially nicotine salts, are always consumers. You know, every consumer is a laboratory in 2 feet. Right? Every consumer is a laboratory. Of course, the consumer guides him or herself by the taste. And so you can really see, and there is a couple of demographic studies that show that high levels of nicotine are used by low-power devices. So some of the studies that we checked, they had nicotine salt at 36 milligrams per milliliter in these monsters. Of course, this is completely unfamiliar. Consumers would never do that. And also, some of them had predominantly propylene glycol, which is also not used in this type of devices. So yes, e-liquids are important. And in these studies that we looked, there was no correlation or very weak correlation between consumer usage and the type of liquids.
Any more questions?
You've obviously highlighted an issue here. Do you have plans to publish this work and perhaps call out some of these studies?
Well, that's another interesting question. We have been trying to publish this study for over a year, and it has been rejected even with referees, with reviewers being favorable. It was rejected by the journal Toxics. I'm not ashamed of saying it. And we appealed. The journal reconsidered, and it was sent to the same editor. And this was a rejection without reason, because the referees were favorable. Well, they demanded changes and so on, and we did these changes and so on, and the editor suddenly said goodbye. And the other journal, we were not allowed to reply to the referees. It was rejected. And now it is now on the balance in a very similar situation. And what happens is that, look, there's one problem here of interpretation. Of the 40 studies, only 14 gave sufficient information to reproduce them, because we did replicate them, right? So, but only 14 gave sufficient information. However, you can deduce the vacuums of information, because if you say the device like this, well, this device, it's not likely to be used with 1.5 ohm. So by a series of deductions, we found out. But the reviewers say, you say it might, it could, it would, likely, you are speculating. There's no science here. We have to face this type of arguments with the referees, right? But yeah, we want to publish it, and now we have 67 studies. Now these 67 studies are using different devices and different setups, so it is much more complicated, because here we look at studies that use the same equipment, right? Now there are different equipments, and also we have revised in previous papers studies on metals and organic byproducts, and we found the same problems. And also something important that comes from these studies, and it is very general in preclinical studies, is lack of information on aerosol generation. There's a study here, X, take any study, and they examine some ADN problems in cells or in mice, or whatever biological problem you want. And so I say, I want to replicate this. Okay, here, bring the mice, bring the cells, bring the whole thing. Now we take a vape, and we're going to put aerosol. But what power they used? What coil they used? These are unreproducible. And in experimental science, this is a very serious issue. And in fact, we have a replicability clinic. And a lot of the preclinical studies on vape have this problem, because they do not provide sufficient information on the aerosol generation. You have the very complete description on the biological issues. These are described in full detail with minimal, everything is described. But aerosol generation, vacuum. So there is a problem of replicability in these studies.
It's a good point, actually.